Hello students, let us start today's class. In the last class, we have done up to question number 2 of exercise 11.2. Isn't it? Okay. Up to question number 2 has been already done. Now, let us start question number 3. What is in question number 3? So, open your books, all of you, my dear students. What is question number 3? The length of the fence of a trapezium shaped field ABCD is 120 meter. Okay. If BC equal to 48 meter, CD equal to 17 meter and AD equal to 40 meter, find the area of the field. Side AB is perpendicular to the parallel sides AD and BC. Okay. See, this is the trapezium shaped field. Okay. This is the field. A, B, C, D. So, given the length of the fence of the trapezium shaped field, the length of the fence is given. So, fence, where the fence is put, my dear students? In the boundary. Is it? That means length of the fence will be equal to the total length of the boundary. Total length of the boundary means what? Perimeter of the field. So, what is given? Given length of the fence of the trapezium shaped field ABCD is 120 meter. That is, the perimeter of the field will be, that means 120 meter. Now, here given is what? The length of this side is given, BC given, DC given, AD given. Okay. And one more thing it is given is AB. The side AB is perpendicular to the parallel sides AD and BC. It is also perpendicular to AD. That means what? This is what? The perpendicular distance means it is the height. Am I right? It is the height. Okay. Now see, what you want to find your, how to find the area of a trapezium? Area of a trapezium, the formula is half into H into A plus B. Means H is the height of the trapezium and A and B are the parallel sides. Isn't it? So, parallel sides are known. This and this are the parallel side. Now, what is remained? Remained is to find out the height. What is the height? AB is the height. Now, as the perimeter of the trapezium is known to you, that means perimeter of any figure means what? Sum of the sides. That means can I write that AB plus BC plus CD plus AD will be equal to the perimeter, because perimeter means sum of the sides. Okay, written. This, that means AB plus BC is 48, CD is 17, AD is 40 equals to 120. Now AB plus these three sum up to 105, 120. Now AB equal to 120 minus 105, that is AB equal to 15 meter. That means what? Here one line I have missed, that is, we can write, that is height of the, that is height is equal to 15 meter. Am I right? Height is your 15 meter. Right? Got it? Now therefore the required area of the field means trapezium shaped field. So what? Half into H into A plus B. Don't forget to mention the formula. Now half into AB. Okay. AB is the height. Parallel sides are AD and BC. Okay. These are the parallel sides. So put the values. Half into what? 15 is the height. Then your 40 plus, what is it? 48 square meter. Area will come in square meter. Isn't it? Okay. Clear to me? Now, let us go to the next page. Now see, 40 plus 48 is what? 88. Now 2 1s are 2. Then 2 4s are 8, 2 4s are 8. That means 15 into 44 is 660 square meter. So this is the what? Area of the trapezium shaped field. Okay, my dear students. Now let us come to question number 4. These images already given in the last class. Okay, the images are already given in the last class. Today I am giving the video of this. Okay. Now question number 4. What is question number 4? The diagonal of a quadrilateral shaped field. It is the quadrilateral shaped field. The diagonal is given 24 meter. Okay. And the perpendiculars dropped on it from the remaining opposite sides are 8 meter and 13 meter. Now, perpendiculars dropped. These are the two vertices we have used to draw the diagonal. Now, what are the remaining vertices? Remaining vertices are these two. Now, from these remaining vertices, perpendiculars are dropped on the diagonal. So, the length of the perpendiculars are 13 meter and 8 meter already drawn. Now you have to find the area of this field. Okay. So you have got the formula, my dear students. Area of a general quadrilateral. Can you remember? Half into D into H1 plus H2. D is the length of the diagonal and H1 and H2. What? H1 and H2 are the what? The length of the perpendiculars drawn from the opposite vertices on the diagonal. Okay. Now given the diagonal of the rectangular shaped field 24 meter, the length of the perpendiculars dropped on it are 8 meter and 13 meter. Always remember, my dear students, first of all you have to draw the figure if figure is there. Then you have to write the given information. Then you start with the formula, put the values in the formula and find the solution. Okay. The required area of the field, half into D into H1 plus H2. Half into D is 24, H1 plus H2. Okay, then 12 is 24, 12 into 21, that is 252 square meter. This is your area of the quadrilateral shaped field. Okay. Now, let us go to the next question. Clear? Now, the next question is question number 5. Question number 5 is, the diagonals of a rhombus are 7.5 and 12 centimeter. Okay, you have to find out the area. My dear students, in this exercise, your syllabus is up to question number 5. 6 to 11 are already what? Omitted from the syllabus. Clear? Okay, up to question number 5. So, this is the last question of your exercise 11.2. After that, we will have a new set of formulae again, as I told you earlier. New set of formulae which will cover exercise 11.3 and 11.4. Okay, now see. 5. Question number 5 is, the length of the diagonals of a rhombus are given to you. Given, this is the figure. This figure is not given in the book. I have drawn. If you want, you can draw. If you don't draw also, no harm, because figure is not asked to draw. Plus, it is not given in the question also. I have drawn to make you understand more clearly. So, given the length of the diagonals of a rhombus are 7.5 centimeter and 12 centimeter. Okay. Therefore, the required area, half into D1 into D2. D1 and D2 are the diagonals. So, 1 by 2 into 7.5 into 12 square centimeter. Okay. That means now 2 1 2, 2 6 12, 6 into 7, 40, 6 into 7.5. 6 into 75 is what? 6 5 30, 0 carry 3. 6 7 42 and 2, 45. 1 place of decimal. So, it comes to be 45 square centimeter. So, with this, we have come to the end of this exercise. Okay. Now, we'll have a new set of what? Formulae for starting the next 2 exercises. Okay. Let me go to the set of formulae. Now, see. Next, now these 3, one in your first page, it is your formula 1, 2 and 3. Now, this will cover the surface area. Here, in this set, we will be getting surface area of a cube. Cube means a 3-dimensional figure where length, breadth, height all are equal. Is it not? Is it or not? Yes. And cuboid means length, breadth, height are different. 3-dimensional figure, length, breadth, height is there, all are different. Okay. Now, surface area. Surface area means here, my dear students, total surface area. We don't write the word total, but surface area means the total surface area. Total surface area means a cube has how many faces? A cube has how many faces? 6 faces, obviously. 6 faces, na? A cube has how many faces? 6 faces. Let me show you with the help of a matchbox. Wait. See, my dear students, this is a box, na? This one is a box. See, this is a cuboid. Length is, this is the length, this is the breadth, and it is the height. See, length, breadth, breadth, and height. See how many faces are there? 1, 2, 3, 4, 5, 6. See, 1, 2, 3, 4, 5, 6. See, 1, 2, 3, 4, 5, 6. 6 faces are there. That means maybe a cuboid, what I have shown you now, it is a cuboid because length, breadth, height all are different. Is it? Okay. Now see, cuboid. Maybe a cuboid, maybe a cube. How many faces are there? 6 faces. That means total area of all the 6 faces gives you the total surface area actually. Is it? So in a cube, all the faces will be what? Square. In a cube, all the faces will be square. So how many squares are there? 6 squares. So if L is taken as the side of the cube, that means one side, one face will be having what? L square as the area. So how many faces are there? L square, 6 faces. So L square, L square, L square, 6 times. 6 times added. L square plus 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 L square. For 6 faces. That is why 6L square. Got it? Got it? Actually, surface area means total surface area means the total areas of all the surfaces. That is, now this is the concept. Now you have to memorize the formula where surface area of a cube equal to 6L square, where L equal to side of the cube. Write down properly, my dear students, in your copy. Okay, write down very carefully. Give pause in the video and note it down. No problem. Give pause and note it down. Okay, now see where L is the side of the, see, this is the length, this is the breadth, and this is the height. Understood? Okay. Now surface area of a cuboid. Cuboid means, you see, how many, again 6 faces will be there. Each face is a rectangle. This is one rectangle, back another rectangle, this one, below one, here one, 6 rectangles. Clear to me? Okay, so area of one rectangle is length into breadth. In this way, 6 length into breadth will be there. Length into breadth. This one will be length into breadth. This one length into breadth. This one will be breadth into height. This one breadth into height. Is it or not? Clear? And this one again, what? Breadth into length into breadth. This one length into breadth. This is length into height actually. This is length into height. In this way, you will be getting 6 faces. So here comes the formula. 2 into length into breadth plus breadth into height plus height into length. This one comes for the surface area of a cuboid. Understood? Now, this is a cylinder. Cylinder, you see, this is the cylinder, this is the height of the cylinder, and this is the radius of the base of the cylinder. Clear to me? Now, lateral area, surface area. Surface area in cylinder, two surface areas are there. One is lateral surface area. Lateral surface area means this. Suppose this is your cylinder, this pen itself, I am taking the cylinder. If I take this as the cylinder, this is the lateral surface area. And total surface area means area, lateral surface area plus area of these two bases. Lateral surface area means this surface area, this round surface area, round surface area. This is the lateral surface area. Lateral surface area will be 2 pi value, you know, 22/7. R is the radius of the base of the cylinder and h is the height. It is the lateral surface area. And total surface area will be lateral surface area plus area of these two bases. Bases are what? Circular bases. So the formula comes to be 2 pi r h plus r. Total surface area of a cylinder equal to 2 pi r h plus r, and lateral surface area or curved surface area. Lateral is also known as curved. I have forgotten to write. It is a curved surface. Curved surface, you know, curved. If this is a cylinder, this comes to be the curved surface area. Understood? Curved surface area of a cylinder. Clear? So this is all about your surface area. Now come to volume. Now next one is your volume. Volume of a cube, L cube. Volume. Here volume of a cube. Okay. Volume of a cube is L cube. Volume of a cuboid is length into breadth into height. And volume of a cylinder is pi r square h. Here L means the side of the cube. Here L means length, breadth, height. Pi means 22/7. R means radius of the base of the cylinder. H is the height of the cylinder. Understood? It is all about your formula. Okay. Now, let me come to question number 1 of your exercise 11.3. Okay. Yeah. Now see, exercise 11.3, question number 1. See, what is there? There are two cuboidal boxes. Yes, cuboidal means length, breadth, height will be there. Yes, these are the two cuboidal boxes. Already I have drawn the figure. This is box A, this is box B. Okay. Now what is there? Which box requires the lesser amount of material to make? Now you are to find out, if you want to make these boxes, which box requires less amount of material. That means when you will make the box, we will make all the faces. Is it or not? You have to make all the faces, all the 6 faces. So all the for making all the 6 faces in all the materials will be fixed in all the faces. Is it? All the faces are covered of both the boxes. Means what? Total surface area. Area of all the faces will be required. Means what? Total surface area. Now, first one is a cuboid, as length, breadth, height are different. Second one is a cube, as length, breadth, height are same. Now, let us see. Box A. Here, length is given, breadth is given, height is given. Let us find out. For getting which box will need the less amount of material, we first of all, we have to find out both the surface areas. Okay. Now, the box which will have less surface area, that particular box will need less amount of material to make. Okay. Now see, which box? Now see, here length equal to this, breadth equal to this, height equal to this. Surface area is how much? 2 into L into B, B into H into L. See, 2 is there. According to that, what? 60 into 40, length into breadth, breadth into height, breadth into height, height into length. Na? Height into length. Okay, got it? Clear? Now, 6 for 2400, 40 into 50, 2000, 50 into 60, 3000. Now, 2400 plus 2000, 4400 plus 7400. Is it? Plus 3000. It gives you 14,800 square centimeter. This is the surface area of the box A. Now, let us come to box B. Okay. Here is your box B. Side is, it is what? Side of the cube. Am I right? Because it is a cube. Side of the cube is how much? 50 centimeter. Total surface area will be 6L square. L is the side of the cube. 6L square. So 6, 50 square. 50 square is 2500. And then 25 into 6 is 150. Then 00. That means 15,000 square centimeter. Now, box A is having the surface area 14,800 square centimeter. And box B is having the surface area 15,000 square centimeter. So, which one is less? Box A is having the less surface area. Is it or not? Box A is having the less surface area. So, therefore, we can conclude that, my dear students, box A requires the lesser amount of material to make. Okay. So, in this way, 2 boxes are given. By finding the surface area, we have concluded that what? Box A needs the lesser amount of material to make. Clear? So, this is the end of your question number 1. So, with this, let us wrap up today. In the next class, we will be doing your question number 2. Okay? This much for today. Thank you, dear students.